Okay, so in this video, what we're going to do is we're going to put into practice what we saw in the last video. So this is all going to be about sketching a sine graph or a cost graph that's been transformed. Now, every time I get one of these questions, the first thing that I want to do is start thinking what a standard graph looks like, and then thinking what's happened to it. So here I'm dealing with a sine graph. So the very first thing I'm doing is I'm just plotting out where a sine graph would go. So at 90 degrees, it'd be up at 1. At 180 degrees, it'd be back at 0. At 270, it would be at -1. And at 360 here, it would be back at 0. So I know I've drawn my axis. This is quite squashed. But I've done that to give a space for what is to come. So that's just a standard sine graph. Now let's think what's going on. Well, this bit here, and I'm going to put it in very non-mathematical terms, is moved down by 2. So we're going to move everything down by 2. So instead of starting here at 0, it's going to start at -2. Its peak used to be at 1. Going down by 2, that peak will be at -1. Used to cross here at 0, so that's crossing here at -2. Used to go down to a minimum point of -1, so that's now down at -3, and then it came back up to 0. Now, connecting all of that up, my solution, my graph that I'm trying to draw, is just a graph that goes through those points. Okay, and I'm looking at that final graph and I'm going, well, there's my original. Does that look like a graph that's been moved down by some amount? Yeah, it does. It looks like we've taken the highlighter orange curve and moved it down to that red graph. So have a go at the your turn one. First thing, sketch your cost graph. Second thing, what does the 3 out the front do? Third thing, have a go at drawing it. So pause the video, have a go, and I will run through one of those in just a second. Great, okay, hopefully you've had a go with that. So I'm going to start by sketching my cost graph. It starts at 1, comes down to 0, goes to -1, comes back up to 270, and back up to 1. So standard cost graph looks something like that. Now we're going to come in and we're going to plot our new graph. Now our new graph is got 3 out the front here. Then that is a stretch by 3 in y. So instead of 1, I'm going to be 3 times that, so I'm going to be up at 3. Well, 0 times 3 is still 0. -1 times 3 is -3. 0 times 3 is still 0. And 1 times 3 is 3. So our graph now comes down, curves at the bottom, and heads back off up there. So we can see that looks like I've taken my graph and I've stretched it out in the y direction, or hopefully it looks like that. Sorry about slight wiggle here, but hopefully it's something that looked a bit like that. I'm also spotting my -3 should maybe be a wee bit lower, but be as accurate as you can. But it is a sketch, so as long as you've labelled your accuracies clearly, and if you're working on square paper, it's a bit easier. But as long as you've labelled your axes clearly and it can be seen that you stretched your graph and it goes through the right points, particularly the key values at 90, 180, 270, and 360, then that is what we're looking for. Okay, so we're not looking for you to sit there and work out every single value and draw a table, just to plot those key values in the right place. Now, let's look at a couple of examples where we've got 2 things going on. So here I've got cos of 3x, take away 1. So same starting move. I'm going to start by plotting what cos x looks like. Well, it starts at 1, goes to 0, goes to -1, 0, 1. So standard cost curve comes down under the axis and back up. Now I'm going to do this in 2 steps. First step, I'm going to deal with the 3x. Okay. So that is meaning instead of doing 1 curve in 360, I'm going to do 3 curves. Now, I'm going to do a bit of approximation here, but that means what's happening at 90? should now be happening at 30. What happened at 180? Well, a third of that is about 60 degrees. And then what was happening at 270? Well, a third of that is 90 degrees. And then we're back up. So one of our cost curves is happening in there. And then all we want to do is repeat that. So whatever was happening here is going to keep happening again and again. We're going to get that 3 times. So the top of my next one's going to be there. So it's going to come down to the axis, down to -1, back to there, and back up to there. And I'm just kind of, in my mind, splitting these into parts that are 30 degrees each. This one, come down, dip, and back up. So now we've got once, twice, 3 times that we're doing that wave of the cost curve. Second thing that happens is we move it down by 1. So -1 in the end, that's moving the whole graph down by 1, and it's the red graph we're moving. So we've done the first transformation is this bit, so we're now moving that graph all down by 1. So it used to be 1, so there, it used to be 0, moves to -1, moves to -2, moves to -1, moves to 0. And I'm literally just going along my graph, plotting out every point 1 below where it was on the graph, the red graph. So now my graph in black here is our new transformed graph. So this black curve is y equals cos 3x -1. Okay. Now, if you were doing this in pencil, you might even want to just draw each of these graphs in pencil and rub it out when you finished with it. So you could draw your cos x curve, and then when you've worked out what cos 3x looks like, you could rub out your cos x. And then when you moved your graph down, you could rub out your cos of 3x, just leaving your final answer graph. I've done it in different colors of pen, just so it's clear on the video what's happened. Now, last graph here, one for you to have a go at. So this time we've got y equals 2 sine x minus 3. Have a go, pause the video, and I will do that one in just a moment. Okay, hopefully you paused. First thing I'm going to do, plot sine x. So sine x starts at 0, goes to 1, goes to 0, goes to -1, goes back to 0. Now, first thing that's going to happen to this graph, I'll do that in red. First thing that's going to happen to this graph is we're going to stretch it by 2 in the y direction. So instead of being at 0, it's still at 0. Instead of being at 1, it's at 2. 0 times 2 is still 0. -1 times 2 is -2. And 0 times 0 is 0. So our new curve, which is 2 sine x, is that curve. And then second transformation is to move everything down by 3. So I'm taking that point, moving it to -3. Instead of being at 2, we'll be at -1. Instead of being at 0, we'll be at -3. Instead of being at -2, we'll be at -5, which I forgot to put on my scale. Make sure your axes are big enough. And instead of being at 0, we'll be at -3. So our new curve that we're interested in is this one here. So this black graph is y equals 2 sine x -3. And we're finished. Okay, so hopefully it's giving you a feel for some examples. And you will come across things that are not precisely like what I've just done, but hopefully you can adapt the bits of knowledge that you've got to deal with those graphs. Have a go, see how you get on, and work your way through some examples.